In this video, we're going to be continuing the series of making the reinforcement learning agent with deep Q learning. So in this video, we're going to be building part of the custom environment, which is the floor, the grid on the floor, and then the four walls, and then the countdown timer. First of all, what is the environment? The environment is basically it's where the model interacts with something, because the model can't interact with nothing, right? So the model interacts with something, and we can even visualize that like we're doing in vpython. So that's what the environment is. So we will be using vpython, which is the visual python library. So that's going to basically render your 3D graphics in a browser window. And then so to install vpython, you can just open the terminal here. You can just say pip install or pip reinstall vpython like this. I've already installed it, so you can just do that. And then we're going to create environment.py, which I have here. So in environment.py, first from vpython, in vpython we're going to first import, we're going to import the canvas, which I'll explain. Import canvas. We're going to import a vector, box, color, and text or curve. And that's all for now. And then we're going to create our environment class. So to create that, we're going to just say class environment. So we're going to define the constructor, which is the init. So first we're just going to say self.room length. So the length of the room, I have tried all of these values before. For me, 52 is good. Next, we're going to do self.block side length. Basically, what this is, you saw in the preview that there was a grid on the floor. So each side of a box in the grid is the block side length. So we're going to say self.block side length. So that is going to be self.room length divided by 9. So we're going to have 9 blocks in the x-axis, basically. X is the room width, so we're going to say self.room width. That is going to be the, basically it's just going to be the self.block side length. We're going to multiply that by 5. So what this means is we're defining the length of the room, and then we're defining a block length, and then the width of the room is just 5 times the block length, which means the width will be 5. So there are 5 boxes or 5 squares in the grid. So on the floor, there will be 5 boxes in the width and 9 boxes in the length direction. And then we are going to set a wall color. So self.wall color. So this is the color of the wall basically. So that is going to be, it's going to be a vector. Now what a vector is, it's basically just a list of 3 values. It's basically just that. For now, that's the simplest explanation. So for, if you're talking about color, the vector is from 0 to 1. So usually it'll be RGB. So it's a 0 to 255. But here you normalize that and you give it from 0 to 1. So I'm going to go with orange, as you saw in the preview. So orange would be 1.5 and 0. So that's orange. And then self dot the floor color. The color of the floor is going to be another vector. That's actually going to be a darkish black or just a dark gray. It's going to be 0.23, 0.22, and it's going to be 0.235, like this. So basically, this is the RGB value, but it's normalized to be from 0 to 1 instead of 0 to 255. And then you have the floor thickness. So that is 10. So 10 units, whatever the units is measured in. And then next we have the scene. So self.scene, basically this is where it's going to render everything. That's going to be our canvas object. And the title will be whatever you want. I'm going to call it deep Q learning. And the width is 1500, height is 700. You can change this based on your screen. Then the background is basically just, so we imported this color object or whatever. What that is, it's basically just a list of pre-made colors, not a list. It just has pre-made colors in this context. So if color dot, we can say white, but I will say black. So instead of creating another vector and saying 0, 0, 0, it's just color dot black. And then after that, you have the scene camera. So basically, which angle are you going to view it at? Not the angle. This is the position. Scene dot camera dot pos, which is position. So that's a vector of. So I've already changed the values and played around. So it's for me it's 17. I mean 0, 17, and then 27. And then the axis of the camera, basically kind of the direction. Camera dot axis, that is also a vector. It's 0, -7, and -20. Next, we're going to define the floor. So we're going to say self dot floor. That is going to be a box. That's what this is. Basically, it's just a cube, or not a cube, a cuboid or a box in 3D space. So it's a box. The position is a vector of 0. So it's going to start at x0. It's going to be, but the y, this is why we define floor thickness here. So the y will be, I want it to come zero point 0.5 units above 0. So to calculate that, we're going to say negative self dot floor thickness divided by 2 minus 0.5. So basically, it doesn't matter what the floor thickness is, but it's going to be the top of the floor is going to be zero point 0.5 units above y level 0. And then after the position or not x, we still have the z. So z is also 0. And then we have the size. The size is another vector. Size is a vector of the room length, the floor thickness, and then it's the room width. And then we define the color, which is the self dot floor color. And then we have the left wall, so self dot, oh no, we have the back wall. Self dot back wall equals, we're going to say, that is also a box. And then the position is another vector. So the x-axis or the x-coordinate of the middle of the box will be 0. And then the y-coordinate will be self dot room height divided by 2. Because when you assign the position of a box, it's actually the center or the center of the box or whatever object you have, that is going to be at those coordinates. So since if we were to say the box is at y level 0.5, because that's where our ground is, then the middle would be at 0.5. So it would be half on top and half below 0, kind of like that. So because we don't want that, we're going to make it so that the center is half of the room height. That way, the bottom half reaches to the floor and the top half goes to the room height. So it's going to be self dot room height, or okay, we have to define room height. First, we have to define room height. So the room height will actually be, the room height will be 30 units for me. And then we're going to say it's the room height by 2. And then the z-axis is negative self dot room width by 2. So same thing here. So if we want to say the z-axis is 0, so it would be at the center of the floor. It wouldn't be at the back. And since if you go further away from the camera in this context, the z is negative. If you come closer, it becomes positive. So we're going to say negative since it's the back one. Negative one half of the room width. That's the position. And then we have the size. So that's going to be a vector. It's going to be self dot room length, because the size in the x-axis is the room length. We want it to span across the entire length. And then the y-axis is the height. And then the z-axis is 1, because the wall has a thickness of 1. You can choose whatever you want. I've chosen the wall has a thickness of 1 unit. And then lastly, the color is the self.wall color. So now we should just be able to run this and it should work. Okay, so to actually run it, you can't just define the environment, you have to actually have a while true loop, because if the script terminates, then it will stop showing the 3D rendering, of course. So we'll just have a while true loop and then we'll say, let's just pass in the while true loop. So now if we run this, you can see we have the floor and then we have the back wall. So I can zoom out a bit. So we have the floor here and we have the back wall. Now we have to add the remaining 4 walls on the sides. So we will say self dot left wall. That will again be a box. The position is the vector. So the x-axis is negative self dot room length and divided by 2, so that the center is at the left end of the floor. Then the y-coordinate is the y-coordinate is going to be the room height divided by 2. And then the z-coordinate is just 0, because we don't want to move it further from us or closer to us. And then the size is another vector. The x, the size in the x direction is 1. The y is the room height, self dot room height. And then in the z-axis, it will be the room width. And then again, the color is the wall color. Then we have self dot right wall. That's another box. The vector, the position is a vector of the self dot room height, because the self dot room height by 2, because the left wall what was on the left side of the camera, so it was negative x, but the x was negative in that direction, but we want the opposite side, so now it will be positive. So it will be self dot room length by 2, and then the height will be the y coordinate of the center will be self dot room height by 2. And then again the z coordinate is 0. And then the size is a vector of 1 in the x-axis, self dot room height, and then self dot room width, and then the color is the wall color. And now if we run this, you should have all sides. Yeah, now we have all 5 sides, or all 3 sides. If you include the four, it's four. If you include the floor, it's 4 sides. So now we have all 4 sides of the um, room, I guess. And in this video, we're just going to continue, and we're going to make the grids. We're going to make the grid on the floor, and we're going to add the countdown or text. So for the grid, what we're going to do is the grid columns, grid columns. So we want 9 columns, and then we're going to say the grid rows. We want 5 rows, and then the grid Y. So we want it to be just above the floor. So if we set it to zero point 0.5, because the top of the floor comes to 0.5 units. So if we set it to 0.5, then they'll kind of be fighting for the z-axis. So we'll set it to 0.5 plus 0.01, which will be 0.15 or 51. And then the line radius, which is the radius of the line, basically since it's the thickness of the line basically. So that will be point 1, or we can say 0.02. And then we're going to say self dot grid lines. So we're going to create a list, and we're going to make a for loop for I in range. Going to say for I in grid columns plus 1, because if we just do grid columns, it will go to grid columns minus 1. So we're going to add 1 so that it cancels out. Then we're going to say the x position equals the negative self dot loop length by 2. So the self dot loop length by 2, self dot loop length by 2, and we're going to add I times, so basically the iteration, the self dot room length by grid rows or grid columns, grid columns. So what this will do, will basically just describe the x coordinate of it, and we're going to say the start of the line equals a vector. So x grid y negative self dot room width by 2, and then the end is another vector. It's again x and grid y, and this time it's just room width by 2. It's positive. And we're going to say self dot grid lines. We're going to append. We're not going to append start. We're going to append curve that we import. It's basically just a curved line, and the position is the start and end, and the radius is line radius, and the color is white. Color equals color dot white. And then we're going to say for j in range grid rows plus 1 again. So we're going to say the z equals negative self dot room width by 2, and we're going to add a j times self dot room width by grid columns or grid rows, self dot room width by grid rows, and then the start is going to be a vector. So it will be negative self dot room width or room length by 2, and then the y-axis will be grid y. The z-axis will be just z. The n will be a vector. It's going to be room width self dot room length by 2, grid y, and the z-axis is z. And then we're going to say self dot grid lines dot append. We're going to append to the grid line. We're going to append a new line. So we're going to append another curve. The position is start end, and it's just basically the same as this. And that should be almost all. So now we can run the script. Okay, so this needs to be room length, not width. So now it should generate it properly. Yeah, you can see now we have proper grids. So what will happen is the agent will be somewhere in this room basically, and there will be some pressure plates or some blocks. The agent is going to try to hit all the pressure plates, and if it touches the wall, it will get a punishment, stuff like that. So we can calculate the reward based on stuff like that. The reward, again, the agent's only goal is try to maximize the reward across either a short time or a long time, depending on how you set gamma. I'll explain that in the later videos. And then next we have to add the countdown timer. Now we're not going to make it count, but we're just going to add it there so we can use it in later videos. So for that, we're just going to say, for the countdown timer, we're just going to say the countdown text. So we're going to import text again because it's text, 3D text. So we're going to say countdown text, self.countdown text. So that is going to be text, the position, or first we're going to define the text. The text is the, so first we have to also define countdown start. So basically how long does the agent have before we fail it and we restart. So that will be self dot countdown start. So what does it start at? So I'll start it at 15 seconds. So that text will be the string of self dot countdown start, and then the color will be black. Or first we'll define the position. So the position will be self dot countdown pause, and then we have to define that now. Countdown text position, and then we'll define it here, self dot countdown text position. That will be a vector. So for me it's -5, 5, and then negative self dot room width, self dot room width by 2 by 2 plus 0.5. Okay, and then we'll set it to that, and then we'll say the color. The color will be self dot not self dot, it'll just be color dot black. And then we'll set the height attribute. So the height will be 10 units, whatever that's measured in. And then the depth, which means how far is it, or what is the width of it basically. So the depth will be 2. And that should render. So when we run the script, you can see we have the countdown timer in the background, and we have the grid here. And in the next video, we will be actually making this countdown timer count down, and we might add some logic for the agent, and we might add pressure plates, or we might do it in the 2 videos after that or something like that. So that's all for this video. Okay, bye.